Okay, on the sheet that I gave you the other day, we were talking about is the collision elastic at the end of our last class, and that there were two types. I gave you a couple questions to do, but we didn't do this example. So before we go to the questions, let's do this example. So it's a 0.25 kilogram billiard ball moving 5 meters per second. So V1 initial is 5 meters per second. Collides head on with a stationary steel ball. So V2 initial is 0. If the billiard ball bounces directly back, so V1 final is 2.619 meters per second in the opposite direction. And the mass of ball 1 was 0.25, and the mass of ball 2, 0.8 kilograms. So it wants to know, is the collision elastic? But before we can find that, we need to find V2F. And so you're going to use your momentum equation to find V2F, so M1V1 initial plus M2V2 initial will equal M1V1 final minus M2V2 final. M2V2 initial is 0. We're looking for this, so take this over. So it'll become M1V1 initial minus M1V1 final is equal to M2VF, but we want V2F by itself, so divide by M2. So V2F equals, and I'm going to call the original direction positive, so it'll be 0.25 kilograms times 5 meters per second minus 0.25 kilograms, and it's going in the opposite direction now, so negative 2.619 meters per second divided by 0.8 kilograms. So when we do this, we get a V2F to be 2.3809375 meters per second in the original direction. Okay? So now we have the velocity of the missing ball. So now we need to find, is it elastic? So 1/2 M1V1 initial squared plus 1/2 M2V2 initial squared is equal to 1/2 M1V1 final squared plus 1/2 M2V2 final squared. Again, this goes to 0. So 1/2 0.25 kilograms, and the initial velocity was 5 meters per second, and it gets squared, is equal to 1/2 0.25 kilograms. Initial velocity was 2.619 meters per second squared, and if you want you could put a negative in here for the opposite direction, but it's going to get squared, so it's going to end up being positive, plus 1/2 0.8 kilograms times 2.3809375 meters per second squared. Okay, so when we do this first side, you get 3.125 joules. When you do the second side, first term, 0.857395125 joules. Second term plus 2.2675453, etc. joules. So 3.125 joules on the left-hand side. On the right-hand side, 3.1249477 joules. I was going for 3.125. I was going for it to be elastic. You put a check there, and you write the word elastic. Okay? So, and what I said in class was either they'll be equal or the first one will be bigger. Usually I would make, if it was wanted to be inelastic, I would make it a lot bigger difference here. elastic is actually very rare. Most collisions would be inelastic. Most collisions lose kinetic energy in sound or in crumpling the object or something like that. Okay, so from your textbook, number 30. A billiard ball of mass 1.155 kilograms moves with a velocity of 12.5 meters per second. So V1 initial, 12.5 meters per second, towards a stationary billiard ball of identical mass. Okay, V2 initial is 0. After the collision, the first billiard ball comes to a complete stop. V1 final is 0. And it wants to know,
Please go to the stage for a yearbook photo.
In case you didn't hear that, you want it on the stage if you have flannel on. And it wants to know what's V2 final. So M1 V1 initial plus M2 V2 initial equals M1 V1 final plus M2 V2 final. Initially, the second one is at rest. Finally, the first one is. The m's equal each other, so you're left with V1 initial is equal to V2 final is 12.5 meters per second. So determine if it's elastic. 1/2 M1 V1 initial squared plus 1/2 M2 V2 initial squared is equal to 1/2 M1 V1 final squared plus 1/2 M2 V2 final squared. Initially, this term is 0, and the final number 1 is 0. So 1/2 0.155 kilograms times 12.5 meters per second squared is equal to 1/2 0.155 kilograms times 12.5 meters per second squared. I wonder if they're equal. I'm going to go out on a limb and say that yes, they are. Okay? So, yes, elastic. And you could figure out the numbers if you want. I'm just not going to. All right, that was 30. Number 31. Car A with mass 17, 35 kilograms traveling north. Okay, so this way is going to be north. 1735 kgs, traveling north 55, so V1 initial 55 kilometers per hour. Clearly I'm doing this during 5th period. And the second one is 2540 kilograms, and it's initially traveling north. Car B mass is also traveling north, 37.7. So V2 initial, 37.7 kilometers per hour. And it says if the cars stick together after the collision and continue in a straight line, what is their combined momentum? And then was it elastic? Okay, so they're going to stick together like this and go off. So M1 V1 initial, M2 V2 initial will equal M1 plus M2 V final. So V final should equal M1 V1 initial plus M2 V2 initial divided by M1 plus M2. So equals 1735 kilograms times the speed that I need to find my calculator to do that in, plus 2540 kilograms times, I'm going to run out of time, that's why I'm not going to stop and look at my calculator, 1735 kilograms plus 2540 kilograms. Where did my calculator go? And you get a VF. All right, we're going to run out of time here, so I'll come back and do this one with the other questions, okay?